Hello students, let's discuss the question. In this question, we have to find the HCF of the following term. Let's start with the part A. So in the part A, we have to find out the HCF of 18 and 48. So in order to find the HCF, we are going to find out their prime factorization. So 18 is here. So 18 can be divided by 2. When we divide 18 by 2, we get the value as 9. Now 9 from here cannot be divided by 2, but it can be divided by 3. So when we divide 9 with 3, we get 3. Again, when we divide 3 with 3, we get the value as 1. Now we have 48. It is clearly visible that 48 is divisible by 2. When we divide 48 with 2, we get the value as 24. When we divide 24 with 2, we get the value as 12. When we divide 12 with 2, we get the value as 6. When we divide 6 with 2, we get the value as 3. Now 3 can't be divisible by 2, but it can be divided by 3. So when we divide 3 with 3, we get the value as 1. So from here, 18 is equals to 2 multiplied by the 3 multiplied by the 3. And 48 is equals to 2 multiplied by the 2 multiplied by the 2 multiplied by the 2 multiplied by the 3. Look here, 2 is common in both. And look, there are two threes, and in 48 there is only 1 3. So 1 3 is common. So we can say that the HCF is equals to multiple of the common terms, that is 2 multiplied by the 3, which from here is equals to 6. So 6 is the HCF of this term, hence the answer to the part A of the question. In the part B, we have to find out the HCF of 30 and 42. So finding the HCF of 30, look, 30 is clearly visible that 30 is divisible by 2. So when we divide 30 with 2, we get the value as 15. Now 15 can't be divisible by 2, but it is divisible by 3. So when we divide 15 with 3, we get the value as 5. And 5 is divisible by 5, that will be equals to 1. Now doing this for 42, it is clearly visible that 42 is divisible by 2, that is equals to 21. And 21 is divisible by 3. When we divide 21 with 3, we get the value as 7. And when we divide 7 with 7, we get the value as 1. So from here we can say that 30 is equals to 2 multiplied by the 3 multiplied by the 5. And 42 is equals to 2 multiplied by the 3 multiplied by the 7. Look here, 2 is common in both, 3 is common in both. So HCF is the multiple of the common term, that is 2 multiplied by the 3. So when we multiply 2 with 3, we get the value as 6. So we can say that 6 is the HCF of 42 and 30. In the part C of the question, we have to find out the HCF of 18 and 16. So finding their prime factors. So it is 18 and it is clearly visible that 18 is divisible by 2. So when we divide 18 with 2, we get the value as 9. And 9 is divisible by 3. So when we divide 9 with 3, we get 3. 3 is divisible by 3, we get the value as 1. Now we have 60. Again, 60 is divisible by 2. When we divide 60 with 2, we get the value as 30. When we divide 30 with 2, we get the value as 15. Now 15 is divisible by 3. When we divide 15 with 3, we get the value as 5. And when we divide 5 with 5, we get the value as 1. So 18 from here can be written as 2 multiplied by the 3 multiplied by the 3. And 60 from here can be written as 2 multiplied by the 2 multiplied by the 3 multiplied by the 5. Look, the common terms here, 2 is common and 1 3 is common. So from here we can say that HCF is equals to 2 multiplied by the 3, and we know that 2 multiplied by the 3 is equals to 6. So 6 is the HCF, hence the answer to this part. Now let's move to the next part. So in this part we have to find out the HCF of 27 and 63. So finding their prime factors. 27. When we divide 27 with 3, we get the value as 9. When we divide 9 with 3, we get the value as 3. When we divide 3 with 3, we get the value as 1. Now in the same way, we are going to find out the factorization of 63. It is clearly visible that 63 is not divisible by 2, but it is divisible by 3. So when we divide 63 with 3, we get the value as 21. Again, 21 is divisible by 3. When we divide 21 with 3, we get the value as 7. When we divide 7 with 7, we get the value as 1. So here 27 can be written as 3 multiplied by the 3 multiplied by the 3. And 63 from here can be written as 3 multiplied by the 3, which is further multiplied by the 7. So here 2 3's are common. So we can say that HCF of 27 and 63 is 3 multiplied by the 3, that is equals to 9. So HCF of 27 and 63 is 9. So in the part CE, we have to find out the HCF of 36 and 84. So finding their factors. 36, it is clearly visible that 36 is divisible by 2. So when we divide 36 with 2, we get the value as 18. Again, 18 is divisible by 2. When we divide 18 with 2, we get the value as 9. And 9 is divisible by 3. Then we get the value as 3. When we divide 3 with 3, we get the value as 1. Now 84. It is clearly visible that 84 is divisible by 2. So when we divide 84 with 2, we get the value as 42. Again, 42 is divisible by 2. That will be equals to 21. Here 21 is divisible by 3. From there we get the value as 7. When we divide 7 with 7, we get the value as 1. So 36 from here is equals to 2 multiplied by the 2 multiplied by the 3 multiplied by the 3. And 84 from here is equals to 2 multiplied by the 2 multiplied by the 3 multiplied by the 7. So look here, 2 2's are common and 1 3 is common. So we can say that HCF from here is equals to 2 multiplied by the 2 multiplied by the 3. 2 multiplied by the 2 is 4 and 4 multiplied by the 3 is 12. So from here we can say that the HCF of this is 12. Now let's move to the next part. In the next part we are given that, so here in the F part we have to find out the HCF of 34 and 102. Finding their factors. 34 is clearly visible that it is divisible by 2. So this from here is equals to 17. And 17 is divisible by only by 1 or 17. So when we divide 17 with 17, we get the value as 1. Now 102. Again clearly visible that 102 is divisible by 2. So when we solve this, we get the value as 51. Now 51 is divisible by 3. When we divide 51 with 3, we get the value as 17. And 17 is divisible by 17, that is equals to 1. So from here 34 is equals to 2 multiplied by the 17. And 102 from here is equals to 2 multiplied by the 3 multiplied by the 17. Look here, 2 is common and 17 is common. So from here we can say that the HCF of this term is equals to 2 multiplied by the 17. And we know that when we multiply by 2 with 17, we get the value as 34. So this is the answer to the part F. Let's move to the next part. So here in this question we have to find out the HCF of 70, 105 and 175. In order to find their HCF, we are going to find out their prime factors. So 70 is clearly visible that divisible by 2. When we divide 70 with 2, we get the value as 35. Now 35 is divisible by 5. So when we divide 35 with 5, we get the value as 7. When we divide 7 with 7, we get the value as 1. Now 105. From here 105 is not divisible by 2, but it is divisible by 3. When we divide 105 with 3, we get the value as 35. Now 35 is divisible by 5. When we divide 35 with 5, we get the value as 7. When we divide 7 with 7, we get the value as 1. Now next is 175. So here 175 is not divisible by 2, 3 and 4, but it is divisible by 5. So when we divide 175 with 5, we get the value as 35. Now 35 is divisible by 5, that will give us 7, and 7 divided by 7 is equals to 1. So from here we can say that 70 is equals to 2 multiplied by the 5 multiplied by the 7. 105 is equals to 3 multiplied by the 5 multiplied by the 7. And 175 is equals to 5 multiplied by the 5 multiplied by the 7. Look here, 5 is common in both this term and 7 is also common. So from here we can say that HCF is equals to 5 multiplied by the 7. And we know that when we multiply 5 with 7, we get the value as 35. So we can say that the HCF to this part is 35. Let's move to the next part. So in the H part, we have to find out the HCF of 91, 112 and 49. So finding their factors, look here, this is 91 and 91 from here is divisible by 7. So when we divide 91 with 7, we get the value as 13. Now 13 is only divisible by 1 and 13. So 13 divided by 13 is 1. Now 112, it is clearly visible that 112 is divisible by 2. So when we divide 112 with 2, we get the value as 56. Now 56 is also divisible by 2. From here we get the value as 28. Again 28 is divisible by 2. We get the value as 7. It's 14. When we divide 14 with 2, we get the value as 7. When we divide 7 with 7, we get the value as 1. Now 49. We know that 49 is divisible by 7. So this from here is 7. 7 divided by 49 divided by 7 is 7. Again 7 divided by 7 is 1. So from here we can say that 91 is equals to 7 multiplied by the 13. 112 is equals to 2 multiplied by the 2 multiplied by the 2 multiplied by the 2 multiplied by the 7, and 49 is equals to 7 multiplied by the 7. So look here, 7 is common in all these three terms. So from here we can say that the HCF of these numbers is 7. So 7 is the answer to this part. Now let's move to the next part. So in this part we have to find out the HCF of 18, 54 and 81. Finding their factors. 18 is divisible by 2. When we divide 18 with 2, we get the value as 9. And when we divide 9 with 3, we get the value as 3. 3 with 3, we get the value as 1. Now 54. 54 is divisible by 2. So when we divide 54 with 2, we get the value as 27. Now here 27 is divisible by 3. When we divide 27 with 3, we get the value as 9. Now 9 is divisible by 3. When we divide 9 with 3, we get the value 3. Then 3 is divisible by 3. From here we get the value as 1. Now 81. From here 81 is divisible by 3. So that from here is 27. Now when we divide 27 with 3, we get the value as 9. When we divide 9 with 3, we get the value as 3. When we divide 3 with 3, we get the value as 1. So from here 18 become equals to 2 multiplied by the 3 multiplied by the 3, and 54 become equals to 2 multiplied by the 3 multiplied by the 3 multiplied by the 3, and 81 from here become equals to 3 multiplied by the 3 multiplied by the 3 multiplied by the 3. So look here, in all this 2 3's are common. So from here we can say that the HCF of 18, 54 and 81 is 3 multiplied by the 3, that is equals to 9. Hence the answer to this. So here we have to find out the HCF of 12, 45 and 75. Finding their factors. It is clearly visible that 12 is divisible by 2. So when we divide 12 with 2, we get 6. Again 6 is divisible by 2, we get 3. Now when we divide 3 with 3, we get the value as 1. Now 45 is clearly visible that it is divisible by 3. When we divide 45 with 3, we get the value as 15. Again 15 is divisible by 3, we get the value as 5. When we divide 5 with 5, we get the value as 1. Now we have 75. When we divide 75 with 3, we get the value as 25. Now 25 is divisible by 5. When we divide 25 with 5, we get the value as 5. Then 5 divided by 5 become equals to 1. So from here we can say that 12 is equals to 2 multiplied by the 2 multiplied by the 3. 45 is equals to 3 multiplied by the 3 multiplied by the 5. And 75 is equals to 3 multiplied by the 5 multiplied by the 5. Look here, only 3 is common all this term. So from here we can say that HCF of 12, 45 and 75 is 3. So this is the answer to given question. So students, in order to solve this problem, we use the basic concept of HCFs and number. I hope you understood the concept well. Thank you.
Don't forget to like and subscribe.